Let's get to today's program. We have the structural masonry special inspections. This is our description and our learning objectives. Also continuing education credits. We have 1.0 MISL professional development hours, and you have 1 AIA-LU HSW. Certificates and evaluations will be sent directly from me, so look for those. Here's our provider's statement as required. Today's giveaway is the Inspector's Handbook, the 11th edition. We'll have 2 of those, and I also have a couple of the Pocket Guide for Brick Construction. We'll give away those. A little plastic box will be coming around. If you'll put your name or business card in there, that'd be great. Today's sponsor is John J. Smith Masonry. Smith Masonry is a family-owned company, has a long history of excellence, and is surrounded by industry experts who dedicate themselves daily to their craft. You can see their commercial, industrial, institutional, and hardscaping work throughout Missouri. For craftsmanship, integrity, the best safety work practices, work with Smith Masonry for the most important masonry needs today. We do have Brian Smith here from John J. Smith Masonry. Thank you so much, Brian. Would you like to say anything? Thank you so much, Brian. We appreciate you. And today's speaker is John Chrysler. He has been active in the masonry industry since 1968, working for a large commercial masonry contractor for 25 years, then joining the Masonry Institute of America in 1993, where he served as executive director until his retirement in 2021. He has held contractor licenses in California, Nevada, and Hawaii, and is a licensed PE in California and Arizona. Additionally, John is a certified structural masonry inspector for both International Code Council and California Division of the State Architecture. He also serves as the ICC Exam Development Committee for Masonry Inspection. Chrysler is past president and fellow member of the Masonry Society and has always served on the TMS Board of Directors. He has actively served on TMS Committee 402-602 since 1996, chaired the Construction Requirements Subcommittee for 9 years, and was, in 2022, TMS 402-602 Main Committee Chair. Chrysler is frequent presenter of seminars and webinars on design, construction, and quality of masonry. As director of the Masonry Institute, Chrysler was involved in developing and updating more than a dozen publications based on the International Building Code and IBC referenced standards. So please give a warm welcome to Mr. John Chrysler.
Thank you. I don't think so. I pushed the wrong button. Yeah, there we go. Thank you, Margie. I know why you wanted to start 5 minutes early after talking about me like that. Anyway, got a long presentation here today, so I'm going to go quickly. But the good part is about it is that all the slides are on the handouts in front of you. So if I skip over some stuff fast, it's probably because you have the slides that you can read. I don't need to read them for you. Today I'm going to talk about the IBC Special Inspection Provisions, which are contained in the what most people call the code, but it's really a standard. It's not the code until it's adopted by the IBC, the International Building Code. So just to clarify that, because many years ago, about 25 years ago, I started calling it a code. Somebody says, it's not a code, it's a standard, and then explained it to me. But if you want to call it a code, that's okay, because that's what everybody else does. The learning objectives, I don't have to go through it because it was already on a previous slide. And I'm going to start off going into the meat of the whole thing. I'm going to give you some typical structural notes. And when I give these notes, I'm going to tell you what's good and what's bad about it. If you look, this is a great line inserted just below the structural notes title. Structural notes shall define the general design and material requirements and are intended to supplement but not replace the project specification. In other words, I want it to enhance what's in the project documents, enhance what's in the code, not duplicate them. And then that's a good one. And then we have the general reference to the specifications, and also material workmanship workmanship and design shall conform to the reference building code. That is a great line. Why? Because it covers everything. You don't really need to say anything more. If your project specifications only had that, you would have enough. But we really do want to put a little bit more in there. Some typical structural notes, which I find a little bit flawed. If you read them, the CMU compressive strength, unless noted otherwise, F'(m) equals 2,000 psi. What the heck does that mean? The F'(m) is a design threshold. It's what the designer puts in there. This note suggests that the F'(m) is the actual compressive strength, and knowing what the F'(m) is will help. And is it exactly equal to 2,000 psi in the field? No, it's going to be above that. We want it to be above that. The mortar shall be type M of all walls. There's 4 different types of mortar, M, S, N, and O. And we don't want the mortar to be overstrength because you'll lose bond. The more cement you put in a mortar, it drives it up to type M, but you're going to lose bond. And if you lose bond, it's probably going to crack, the walls are going to leak, and you're going to have some other types of problems. We want to use the softest type mortar possible. Usually a type N mortar in Missouri is going to be just fine. And it's going to have a very, very high compressive strength, even though the number associated with that in the table is a lot lower. The actual strength in the wall is a lot more. And as far as the grout goes, it's specified to be here 2,000 psi. And it's not needed to be 2,000 psi. We have a perception that stronger is better. Not necessarily. We want it to be compatible. So we want the grout to be limited to 2,000 psi unless a higher strength is required. In other words, if your design strength is over 2,000, like say 2,500, then you would specify 2,500. Horizontal joint reinforcement. There's a code issue going through right now on the horizontal joint reinforcement of whether it should be a ladder type, which is perpendicular cross wires, or the truss type, which is the diagonal cross wires, because the truss type can interfere with the vertical reinforcement. So there is a discussion within the code arena trying to get that resolved to mandate a type of joint reinforcement, which is probably not a good idea to mandate it. So you might want to specify that the ladder type reinforcement is preferred if you have vertical reinforcement in the system. And then as far as the construction joints, this is probably cut and paste from previous, because the recommended spacing for control joints has been as much as 60 feet some 30 years ago, down to the current 25 feet. So in this specification, it says 3 times the wall height, which is more than the recommended recommended spacing for a wall height ratio, or 30 feet. So the NCMA note should be referenced for this, and then submit written construction practices prior to the start of necessary conditions. I love this line, because how would you interpret it? It sounds great, but I think what the engineer expects and what the contractor is going to provide are going to be entirely different. So I'm going to suggest some better structural notes when it comes to this. Furnish and install masonry materials conforming to TMS 602 and specification for masonry structures. That says it all, because that encompasses all the relevant and current, that's a key word, current ASTM standards for masonry construction, because ASTM standards do change from time to time. And we want to make sure we draw in the current standards. And then the CMU, the ASTM C90 just specify normal, medium, or lightweight, and designate higher strength if required. Now, here's an interesting thing. I was talking to Bruce earlier today, and he was showing me a project specification that had regular weight. I don't know what regular weight is. Is it normal weight? Is it heavy weight? It's not lightweight, we know that for sure, but it could be normal weight or medium weight. So that needs to be clarified. But specify it in accordance to what is in the ASTM standard. And then mortar ASTM C270 type MSN, or possibly O, by property. And the key word here is or proportion, not both. I have seen, in my lifetime, I've seen literally hundreds of project specifications which intermix the proportion and property aspects of mortar. And in 9 times in 3 ASTM standards, we try to explain why you don't combine them both, how they react differently in the field than in the lab. But apparently we haven't done a very good job, because people still do it. people still specify them according to both. And then as far as the course grout goes, if we just specify it according to ASTM C476, we don't even have to put the minimum compressive strength in there because it's already in the TMS 602 standard. And then for horizontal construction joints, the current recommendation, and it could change tomorrow, I don't know, is 25 feet or 1.5 times the panel height. So those are some of the differences. And then so here's that last line, submit the construction procedures. Here's what I think the engineer meant to say: submit written procedures for grouting prior to the start of construction. That is a huge difference than the construction procedures. Anyway, furnish and install masonry in accordance with TMS 602 specification for masonry structures is the most important one because that covers everything. In case you miss something, the contractor will be obligated to do it according to what is practice and according to what the code says. Now, as far as navigating the code, I'll talk about that a little bit. Which code applies is a question I often ask because the code does change and you might have two different jobs on opposite sides of the street. One is under a different code than the other one, and I'll explain how that works. The history of inspection is kind of important to understand why we got to where we are today and some of the nuances that have gone along with that. And the special inspection according to TMS 402 and 602 is a given. It gives you the roadmap on how to specify and implement an inspection program. And what are the key inspection items of TMS 402? I'm going to be a little redundant on that towards the end because I think there's three particular items that are of utmost importance that need to be followed, and how special inspection can affect overall quality in a positive way. Now, when we look at navigating the code, which code are we talking about? Because we have the International Building Code, we have ASCE 7 that applies, and then our TMS document, TMS 402 and 602, and then some ancillary documents like the ASTM standards and masonry inspection requirements, which may be published. Those are not necessarily as binding, but they give you guidance on what the code wants you to do. This is kind of a cool slide called I call it the code timeline, because we have various codes. If we look at the ASCE 7, it's published every 6 years. Last time was in 2016, and then again in 2022. And then we have the IBC, the International Building Code, which is published every 3 years. And that's the one that's usually referenced in the project documents by the building officials, the jurisdiction having discretion. And then we have the TMS 402, which used to be published on a 3-year cycle, but we changed to a 6-year cycle because it gave everybody, the designers, the contractors, a lapse of 6 years between the time they had to learn the new provisions of the new code. And if you look at the 2018 IBC, it's going to reference back to two other standards that come into play. One is the TMS, that's on the bottom, the TMS 402, and the ASC E16. Now, fast forward to the 2021 IBC, it's still going to reference the 2016 versions of the TMS 402 and ASC E7. But then again, when you move forward to the 2024 IBC, we have more current standards to reference in 2022 and 2016. And if a job was designed under the 2021 IBC and built under that on this side of the street, and the 2024 on the opposite side of the street, you're going to have different rules to follow because you're going to have different codes that apply, correct? So that's why I say it's kind of important to know which code applies when you're looking at the codes. If you look at how the TMS 402 and 602 is broken down, and I've used the acronym TMS, and I apologize for not saying before, TMS stands for the Masonry Society. It's the Masonry's Industries version of putting out this document. If you look at it, it's broken down into several parts. The code part, or the TMS 402 part, is broken down into 5 parts actually. And if you look at part 1, 2, 3, 4, one is general, one's design, one's engineered, one's prescriptive, and then you have the appendices. And you notice that I've crossed out appendix 1 and 2 there because they were taken out over the last cycle. They were deleted, but there's still a placeholder for them because references will reference back, and we need to know that it's not some totally different section there. But if you look at the yellow areas, those are the ones I'm most concerned about when it comes to masonry inspection. On the first column there, Part 1 General, we have Chapter 3, which is quality control, quality assurance, and construction. And then on the right-hand side, we have the specification part, which is the second half of the document, the TMS 602, and that's Part 1 General, Part 2 Materials, and Part 3 Execution. And what is this? Is anybody in the room, and I think everybody in the room is familiar with how CSI format is laid out? You have Part 1 General, Part 2 Products, and Part 3 Execution. It's not accidental that the specification, the TMS 602, was put into that format. So those are the two. Well, first of all, we're interested in how the code is broken up, and then those are the two sections that we're interested in today. So when we look at that, why do we test and inspect masonry? First of all, because the code makes us do it. You know, we don't have a choice. And there's a lot of benefit to it. There's some structural design requirements. If we don't watch our quality on how things are built, could a contractor, and it's not going to be anybody in this room because they're really interested in the quality, that's why you're here today, could a contractor take shortcuts? Yes, and we don't want that. And that's what we're trying to do, eliminate those kind of things so the quality is there. Quality control and quality assurance are both part of the code. One is defined and one is not. Quality control is the plan that we put together, and quality assurance is how the contractor carries it out. And we want to make sure the workmanship is going to be up to what is expected. And there's economy here because, for example, if you get things done right the first time, what does it eliminate after the job is over? It eliminates the lawyers. So there can be a large economy of scale there. And then we're concerned about the aesthetic. We want the job to look right. It's not just structural. We want the job to look good. And inspection and testing of masonry will help to assure that happens. It doesn't guarantee it, but it helps to assure that that happens. What is special inspection versus just general inspection? Well, IBC defines it, and it's full, continuous, or part-time inspection of materials fabrication, installation, and placement of components and connections. Now, there's one sometimes ambiguous term. What is part-time or periodic inspection? It's not well defined in the code. It doesn't say 20%, it doesn't say 50%. It's up to the discretion of the designer to say how much they are satisfied with. It could be half the job, it could be once in a while, it could be once a week, but it should be random, you know, so that it's not a Tuesday at 10 o'clock, the inspector is going to be here, so we better be good, but we don't have to worry about it the rest of the time. You don't want that. And inspection ensures compliance with the code and contract documents. It doesn't guarantee it, but it assures it as best it can. As I mentioned, we have continuous inspection. That's kind of a no-brainer because that means somebody's there all the time watching you. That's okay on certain types of jobs. If you have it's politically incorrect, but I still call it an essential facility like a hospital or a police station or a disaster shelter, you probably want to have continuous inspection on there because every single element is most likely critical. If you have a convenience store, periodic special inspection once in a while is probably adequate. Maybe even 5% would be adequate, but you just want to make sure that the job is not going to fail under a disaster of some type where people are going to get injured or even worse, killed. On a job, both types of inspection could be possible. Take a hospital, for example, with some outlying buildings, a garage, a parking structure. That might require continuous inspection on the main facility, and on the ancillary facility, a part-time inspection. So it's possible to have both types of inspection. Now, how much periodic inspection is needed? As a side note here, TMS commentary has something that says the quality assurance table is there, and it needs to be defined by the architect or engineer as to what the timing of periodic inspection should be. And that doesn't mean, like I say, Tuesday at 10 o'clock. That might mean every week, pick 4 hours that you want to inspect. You know, random is what we're concerned about. Okay, back on the presentation, the structural observation might be necessary by a structural engineer that knows, that feels that job This is a critical element, so I want to make sure I'm going to be out there to make sure it's done right. I don't want them to take any shortcuts whatsoever in the super critical element that I have as a designer that I'm so concerned about. It's been keeping me up at night, so I'm going to make sure they do it right. That's the kind of thing structural observation is all about. And on a job, structural observations and special inspections may be required. So you can have a combination of both. As I mentioned, quality assurance is defined in the code, and as you can see, it's the alternative or procedure that the designer puts in place. Quality control is not specifically defined in the code, but there is a dictionary definition for it, and it leads to the contractor's responsibility in putting together a program to make sure that the quality assurance plan is carried out. Now, I paraphrase it in a nice little way as far as how it fits in and what does it do. Where does it fit in? The special inspection is concerned with both, but quality assurance is the plan. Here's the plan I lay out for quality on my job. Quality control is implementation of the plan, how we make sure it is done. Okay, and then when we look at the IBC inspection requirements, it's kind of a circular argument here about what is required, but it's required in several places. If you look at in the general and administrative provision, section 110, there is a paragraph that talks about general inspection requirements. So it's not something that's optional, it's required. Chapter 17 is specific to inspection, and then chapter 21 turns you back towards the masonry section turns you back towards chapter 17 because they have a paragraph in there that's specifically referencing chapter 17. And then as far as chapter 14, which is exterior wall coverings or veneer, not too much on inspection, but veneer is defined as an exterior cladding. In the previous codes, there used to be a definition where it was defined as a non-structural element. They've gotten that out. They've kept the concept, but they've defined it differently. So as far as chapter 21 referring back to chapter 17, the link is there, but this is IBC, these are the IBC requirements. How does that reflect on TMS 402 and 602? Because it does exist there. If you look at chapter 17, it will send you down to TMS inspection requirements, and in TMS section 402, I highlighted the yellow box where chapter 3 is concerned about quality control specifically, and then it will lead you over to TMS 602, most specifically, Article 1.6, which is the quality assurance program. It talks about what the qualifications are, what is required, and that's where you get your guidance, your guidelines to implement the quality assurance program. So moving on, the history of inspection. This is kind of important to understand because it does go back a long way in all three codes. When I say three codes, I mean the one that predated the International Building Code. That is the Uniform Building Code, the BOCA Code, and the Southern Building Code, SBC. If you look at the 1943 IBC, that's the first time I found it, at least in the West. It had a requirement for masonry inspection, and it said, on masonry where the design is based on stresses in excess of 50% of those allowed in chapter 24, then you must inspect. What does that mean? That means if I design something for 2,000 or if I design something for 1,000 psi actual stresses, I've got to double it if I don't inspect it. So there's some teeth in that. What was the rationale for that? Well, knowing how they did things back in 1943, I suspect it was something like this. That feels pretty good. We're going to go with that. I don't think there was any rationale for that. They just say double is better. It's twice as good. So when we fast forward about 50 years to the 1997 UBC, we have some allowable masonry stresses in the allowable stress design provisions that made it optional. You don't have to do special inspection, but if you don't, that rule of doubling the stresses still applies. As far as the strength design provisions, section 2108, it's required. You have to do some special inspection. It doesn't say it has to be continuous or periodic, but it says you have to do some special inspection. Otherwise, you don't get to design it this way. That was the inference of the code. And then if we look at the 1997 UBC, there's some confusing language in here that's hard to interpret. But if you take it piece by piece, you can do it. For masonry, other than fully grouted open-end hollow unit masonry, that's a specific type of masonry that's excluding one type and including everything else. When do you do it? During preparation, taking of grout or prism, taking of prisms or test specimens, and then placing of all masonry units, and then placement of reinforcement, and then during all grouting operations. Kind of confusing, you know, when do you do it? When do you not do it? And then for fully grouted hollow open-end units, it says start during the start of laying units and the placement of reinforcing steel and so on and so forth. Well, we tablized or put that information into tables later on when we moved into the IBC, International Building Code, which was a much, much better thing. And those tables have matured into something much, much easier to understand today. And I'll show you that in a couple of minutes. Then we had the BOCA code, which did have some inspection requirements. And if you look there, it referred to a table. Now, this is about 9 years previous to the slide I just showed you. So BOCA was ahead of its time in developing some form of presentation in tabular table form, which was a lot easier to understand. It references one table there, table 1308.5, which looks something like this. And if you look there in the column, the middle column there, it references ACI 530, which is the earlier designation of this masonry standard, which I showed you a little bit earlier, the TMS 402 and 602. So it's really the same document, but it shows you the inspection task that's required, and it shows you the section reference in the code where you would go to find out what's required. Now, what is missing here? It doesn't tell you, do I have to do it continuous? Do I have to do it periodic? But it is in a table which is easier to understand than that paragraph, which I had to underline in red, right? So, referencing the TMS 402 or the ACI 530 as it was called then, showed you where to find it. And that is something we continue to keep today because it's a very, very valuable tool in understanding what the inspection provisions are. Now, if we look at the SBC, the Southern Building Code, it's a little bit more ambiguous on what is required because it does have some indication in there as far as the inspection service 105.3, and it tells you in the following section what is required or where it's required: building, electrical, plumbing, masonry, mechanical. It doesn't say masonry there, but is masonry part of the building elements? It's going to be, so presumably it's in that. They specifically say foundation, frame, and final is required. So it does exist in the SBC also. And then it talks about reinforcing and structural frames, and the paragraph gives you a little bit more information. Now let's forward to the 2000 IBC, only about 24 years ago, more recent, right? We have a section in there that builds on the tables. Section 1704.5, masonry construction, and then it tells you that it has to be inspected in accordance with the requirements. Now, in the 2000 IBC and some subsequent versions of it, we have tables for masonry, for steel, for concrete, and for wood. And out of those, 3 of the 4 tables still remain in the IBC today. One is not, and that's the masonry. We pushed the masonry table over into the masonry standard, which is kind of a good thing because we get to evaluate it and update it every code cycle based on what's in the material standard. We don't have to try to cross-reference between the IBC and the TMS 402 document, which is really a good thing. So going back to the 2000 IBC for masonry, this is the table that shows in the IBC, and it has masonry inspection, level 1 special inspection requirements for this particular table. And then at the same time, the 1999 ACI 530 and TMS 402 had their table for special inspection requirements. So you have one table over in the masonry standard, one table in the over in the IBC. Not a good thing to have, right? Because they're probably going to conflict with each other. They're not going to be in sync with each other. So ultimately, a couple of code cycles after that, IBC was gracious enough to take it out of Chapter 17, leaving the 3 others in, and defer to the masonry standard for that, which is a really good thing. And we looked at that table from cycle to cycle, making it better and better and better, much better than it would have been in the IBC. So if we look at the 1999 ACI 530 or TMS 402 quality assurance table, and notice too that that's level 3. To try to avoid a little confusion, in the IBC we had level 1, and in the TMS 402 we had level 1. So we changed it to level A and then changed it back to level 1 after IBC deleted their tables. And then we look at the inspection tables, and we start getting a little bit more clarity in that, because we can see, unfortunately, it's like I say, it was level C table for this particular one. We had levels A and B, and a lot of this is kind of confusing, but I'm just giving you some background, not the current. You don't have to understand it, you just understand what was going on. And in this particular table, it was level C, but as you can see down there, we have in the middle columns, we have continuous and periodic. We're starting to bring that concept into play more recently than 2000, so that we have, if you don't need to inspect it all the time, part of the time might be okay, we can do that. But as I mentioned, as far as this particular presentation type of table is now gone from the IBC, and they're just referencing the TMS 402 and 602, which is really a good thing. Now, as far as which table applies, because I've thrown some numbers and letters at you, level 1, 2, 3, level ABC. What applies for my job? You know, we have, I might have a hospital, I might have a strip mall. I bet you they're not going to be the same levels. And that's true, because those levels are defined through what type of building it is that is risk category and how it is designed. Let's say, for example, I have something that is in risk category 4. What's risk category 4? That would be a hospital, for example. And let's say that I've designed it according to allowable stress or strength design, or part 3 of that big matrix that I showed you earlier that had the 4 yellow boxes on it. If I bring those two together, that's going to tell me I need to specify level 3. So it's something that the code is going to drive you to say what the minimum inspection level is going to be. You don't have to try to guess at it, figure it out that way. So the code is going to be helpful there. Now, I say remember this table because in a few slides, I'm going to come back to how it works. But if you look at the current version, the TMS 402 and 602 for 2022, that's the one that would be most current today. If you look at the minimum verification requirements, you can see we have a group of tasks, and depending on whether it is quality assurance level 1, 2, or 3, it's going to tell you whether it's required R or not required NR in that table. That's pretty straightforward, and that gives you levels 1, 2, and 3. So we've had the tables mature to a sense they're a whole lot easier to understand fully. I mean, we could understand the tables as they were 20 years ago, but there was a lot of ambiguity in them where one person might have interpreted it one way, one person another way. So we got some more clarity there, and we're moving forward on that. Now with the inspection requirements, a similar table, not just verification, but now we're inspection. We have, again, the group of tasks, and depending on what quality assurance level it is, it will drive us into whether it's required or not. NR is not required, P is periodic, and C is continuous. Now, I, as a designer, could say, I like that task at P, but I want them to inspect it 100% of the time. Could I change it to C, continuous, in my job? Sure I could. Could I change the C's down to P? No, you can't go lower, but you can go higher in the application of the code. Now, here is one thing, cut and paste. I'm guilty of it, so my criticism is to me also. We are so used to cutting and pasting information from one thing to another, one project specification to another, and if we have something that applies to this job, doesn't apply to this job, might be contradicting this job, we're going to cut and paste mistakes. But the best thing you can do is just take this whole doggone table and put it in your project requirements, your project documents, and then you can cut and paste it from job to job to job to job, and you'll be 100% correct all the time. I think I like that. Or at least reference it It's going to cover you. It's going to cover the field. It's going to make things more clear. And clarity leads to better quality. I like that. Now let's look at the construction. I'm an advocate of pre-construction meetings because I don't know of any project documents that are distributed, whether they be electronically or on paper, that are 100% clear between the designer and the constructor in the field. There's going to be some questions. I detest the phrase from a contractor, well, I've been doing it this way for 30 years. Well, the code's changed a little bit over the last 30 years, Jack. So I don't buy that. But I'm a real big advocate of a pre-construction meeting. There is a provision in the code which strongly suggests it, but it doesn't mandate it. I think a pre-construction meeting can get rid of some lawyers at the end, and that's a really good thing. There's some material testing, verification of materials, compressive strength, sample panels. This is all normal stuff before the beginning of the job. During the construction, there's issues about laying the units, reinforcement, and accessories installed in grouting and masonry. Two of the really key important elements, 2 and 3 there. Reinforcement, the location of the reinforcement, and the grouting, tying the whole system together. They're essential because why? After the job is grouted or after the wall is built, then you're not going to see that stuff. Is it located in the right place? I don't know unless I do some destructive or non-destructive testing, which I wouldn't have to do if the inspector, which has no dog in the fight, would just take a look at it and say, I can verify that that was done correctly. And as far as construction inspection, there's a whole bunch of things here. We look at early stages of inspection, proportions of site prepared mortar. That's not super critical, but it's needed. Reinforcement connectors and anchor. You want the right type of steel. If it's specified to be grade 60, you really don't want it to be grade 80 because it might act a little bit differently in masonry. The grout space and reinforcement location, that is kind of a critical item because that's going to dictate the best performance of the masonry wall and system in itself. Proportions of site prepared grout, if done that way, a lot of the grout is either transit mix or pre-blended, so all you do is add water. And then material compliance with approved submittals, that should have been done already, but making sure that, hey, that's type N mortar, it's stamped on the back, but bagged to be type N mortar, that's what we want. And then placement of masonry units, that's pretty easy to see whether it's during or after the units are placed. And then hot and cold weather construction provisions. If it gets really cold or really hot, it's going to affect the masonry, like it'll affect concrete or something like that. So you have some special guidelines to follow. They're not onerous, but they are something that is going to make sure that your masonry reacts or the masonry performs as it's supposed to be. And the grout placement is critical because not only does the grout have to be put into the wall, it has to be consolidated and reconsolidated. You don't want any voids in the grout because if you have voids, especially major voids in the grout, and I've seen jobs where even when it was inspected, there was major voids in the grout. Now, was the inspector off taking the coffee break or something like that? I cannot answer that, but that's how it can get away from you from time to time. But the reinforcement, the location of that, and the grout placement are really critical things that need to be watched for. Construction inspection, we can look at the quality assurance programs as they are defined in the code, and it will tell you certain things like the program shall comply with the table 3.1 as specified in the TMS 402. And if you look at the structural notes, and I like this set of structural notes because it covers everything without being specific on anything. Sample and test masonry materials in accordance with TMS 602, and it gives the year 22, so we're clear about that. Table 3, quality assurance level, and then you pick the level. That tells you you have to verify all the submittals. And then the next line, it's basically the same thing, but it says inspection, and it drives you to a table for quality assurance level 1, 2, 3. You specify that, and you've got your entire quality assurance program covered. You don't have to put all the detail in there. You can if you want, but when it gets to the contractor, if the contractor doesn't know, then it's going to make them go out and buy this and find out what they're responsible for. I know there's some contractors in here, And it's not directed to you at all, but I am very, very critical of how many contractors will sign a contract, go ahead and commit themselves to build a job, and not know anything about what's in here. And this is code. This is law. Anyway, like I say, if you cite that, then you're covered. And then the structural notes, comprehensive and simplified. Like I said earlier, if you want to take those tables, cut them out, copy them, and paste them into your project specification, I have no problem with that. If I was a designer, that's probably what I'd be doing. Because if it ever comes up at the end of the job and they didn't do something, that you're obligated to do it here, it was in the project documents. Now, whether it's level 1, level 2, or level 3, I would have to cite that, and I would do that. If it's level 3, I'll say, do it according to this table level 3. Bingo. You've said everything you need to say. And as far as the inspection, same thing. Is it going to be level 1, level 2, or level 3? I'm going to specify the level. You're going to do it. Nothing else to talk about. Now, we talk about qualifications, field and lab testing technicians, and the language has been tweaked around a little bit for the 2022 code. For testing agency, it's telling you to use qualified field testing technicians, okay? Make sure the person's qualified. And they don't say too much else in the code itself or in the standard itself. And the inspection agency's duties. For the inspectors, they tell you the same thing, use qualified personnel. But in the commentary, they elaborate saying, here's what we consider qualified personnel. And they'll say, field testing technicians, there's an ACI masonry certification. We expect them to have that ticket or the certification. For the special inspectors, there's the International Code Council, the ICC, Special Masonry Inspection Certification. We expect them to have that. Now, could there be others? Yeah, there could be others, but they're not specifically cited. Here's the deal about getting qualified individuals. This is a real life job with a certified inspection agency. Look at that set of samples. And I know you don't have to have great eyes to see those samples are set on a level table. Do they look level? They don't even look close, do they? And when you start looking a little bit closer, and specifically when you throw a level on it, those specimens were 3 times out of allowable tolerance. This particular situation happened to shut down a job for 12 weeks while they were trying to figure out what was going on. I mean, that's an exorbitant amount of time, but it happened. And I went out to the lab and I took these pictures myself. Here's what's going on with the testing. You have certain criteria in the standard that tells you to test that on a level cap surface because you want your load to go down in a completely vertical direction. And what was happening here is the load was going in a sideways direction, essentially. Now, the geometry is not quite to scale, but it raises the point that it was being pushed to the side and was failing early. It wasn't that the masonry didn't have this compressive strength, because ultimately it did when it went to a different testing lab, but it was being mistested. Unqualified personnel. Here's the deal with masonry prisms, and this was a prism they were testing. You have certain criteria. Your spherical head that applies the load has a dimension from the spherical head to the extreme corner of the masonry. That is a dimension, and that dimension is supposed to equate into the thickness of the spherical head. That's so the load is evenly distributed. When that's not done, then you're going to get more of a point load or an angular load, which is not going to work very well. Anyway, that shows you how big that sucker might have to be. Now, if you look real closely, you can see on the upper part, there's little links to the chains that you have a machine lift that off, because I don't think any individual or 2 individuals is going to lift that off. It's going to be extremely heavy. And those are the kind of things. Here's another thing for a qualified technician, a field testing technician. Taking the masonry grout and putting it into a concrete cylinder. Is that going to work? I can guarantee you failure. Why is that? Because masonry grout, the excess water which we put into grout intentionally, is going to be sucked out by the units, and that cannot happen in a plastic cylinder. So what's going to happen is you're going to have a test which is going to result in an early failure, and you're going to have what I call a failed test result, because the material itself is not failing, it's the testing that's failing. What you want to do is you want to have in a pinwheel, or some people substitute a cardboard box, which I personally don't like because they're never calibrated, but in a pinwheel, you're going to replicate the field condition and you're going to have a successful test. That's what we want to see. As far as project documents goes, talk a little bit more about that. Clear guidance leads to better quality. I think I said something to that effect already. Specify only what is necessary. Usually over-specifying causes problems. Rely more on the material standards, what they're listing. Why? Because they update themselves often, and usually to the more stringent requirements. Example, ASTM C90 concrete block. In 1990, they got rid of the grades and types, and I still see today every once in a while grades and types specified. Or they got rid of it for the more stringent standard. Specify only enough to be clear about the materials and special conditions. You might have ASTM C90, which is like regular 2,000 PSI block, but you might need a 3,500 PSI block. That part you're going to definitely have to specify. Specify only what is necessary, but there is a catch-22 to this. If you look early in the TMS 402 document, it's going to require you, or it's going to ask you, to put all these things in the project documents. Code reference, well, that's going to be their loads. Often I don't see the loads in the project documents, but it's part of the standard. And then other things like specified masonry compressive strength, and you can read down the list. Most of those are applicable, but some of them might not be. And then the concrete masonry units. I'm going to do a little comparison on what was specified and what is better. Like I said, I see this occasionally, the grades and types are specified, and that's with an F'(M) of 1900 PSI. I'm not sure why the F'(M), which is a design system strength, is mixed up with the specification of what ASTM C90 is supposed to be on there. Grades N and S have not been in the standard since 1990 in favor of the more stringent standards, the types in the year 2000. And F'(M) is a system design strength. That's the one word most people use when they look at F'(M). They lose the word design. You got to keep that in mind. It's not what's proven in the field, it's what's back in the designer's office that they need it to be, the compressive strength. And then in 2015, the material standard and the code basically upped that 1900 PSI minimum compressive strength in C90 up to 2000, because all the manufacturers were making it that way, and the quality control standards had been better since the introduction of 1900 PSI many, many years prior to that. Okay, here's a good little exercise. Let's look at some structural notes that listed: provide concrete block of medium weight classification complying with C90 grade N1, like I just criticized, with a minimum average compressive strength of 1900 PSI, 1500 for individual units. All units shall have open end bond beam units and shall be used at horizontal reinforcing. Now, some of the stuff in there was cut and paste from much more previous generations. 1500 PSI for individual units. Well, we're ahead of that right now. All units shall be open end. Even at the ends of walls, at the corners of walls? I don't think that's what the intention was. Better to have something like provide, specify the weight, open end, not all, but just open end concrete masonry units complying with the ASTM C90. Bingo. That's all you need to say. Don't over specify. And then you want to specify which weight it is, and open end is okay. All right, next thing, mortar. ASTM C90 standard specification for mortar is what we want. ASTM C270, I'm sorry. And then we have another standard for mortar, C780, which is how do we test and verify we are getting what we want. And then we have ASTM C1576, how to properly use ASTM C270 and 78. Is that confusing? The answer is yes. We need 3 different standards for one material. Masonry has done themselves a disservice on not telling people what C270 means, proportion or property, not both. Here's 2 different ways to specify it. Well, we couldn't do that. We had to go to 780, and people didn't understand those two, so we had to add another one, 1586. Sometimes we are our own worst enemy. I don't like that. Okay, back to the structural notes. Provide motor complying with C270 type S attaining a minimum compressive strength of 2,000 PSI, 28 days. What? Where did 2,000 come from? It's not even associated with any strength of motor. We have 2,500, 1,800, 750, and 375. It doesn't even come into play. Probably the masonry design system was 2,000 PSI. Oh, I'll make the motor the same thing. Doesn't quite work like that, unfortunately. So how do we fix that? How do we make it better? Let's just say provide type, and we specify the type of motor complying with ASTM C270 by proportion or property requirements if we feel strongly about that. If we leave that blank and don't specify proportion or property, it's going to default to proportion unless proportion won't work. And why wouldn't it work? Maybe the sand gradation is not proper. So it's possible. Anyway, that's a better way to express it. Okay, looking at something else as far as mortar goes, mortar by property, if you look in the lower right-hand part, you see the sweet spot, and where does the intersection come through? When you look at the cement and bond, it comes through in type S or N mortar. Less cement is better bond, but you want to have enough cement for strength. That's why S or maybe even N structurally is going to be adequate. Okay, another structural note. Provide grout compliant with ASTM C476. This is my favorite one. Attaining a minimum compressive strength of 2,000 PSI, 28 days with an admixture, and provide aggregate complying with ASTM C204. Remember what I said about cutting and pasting mistakes? Well, here's one. Not the 28 days, although that's not necessary, and not the additive, which is probably not necessary, but the ASTM C204. I looked and looked up what that was. It's standard test method for fineness of hydraulic cement by air permeability apparatus. What they really meant is ASTM C404. It was a typo, but the typos are making themselves from project to project to project. A better way to say that is provide masonry grout compliant with ASTM C476. That's all you have to say. Why? Because when you go to TMS 402 and 602, they're going to tell you if a higher strength is required, specify it. Put it on the project documents. And then only include additive or admixtures if they're necessary. What is the admixture trying to do? Sometimes the admixtures actually do the opposite of what they're advertised to do, depending on what they come to interface with. So you want to be careful about that. Another one on the structural notes, provide Portland cement as indicated in cast and place concrete notes. This is a fun one. Why is that? It would be better to say nothing. And here's why. If you look at a table, if you look at ASTM C150 cement, all types, 1, 2, 3, 4, 5, are allowed for cast and place concrete. If you look under C270 and C476, mortar and grout, they only want types 1, 2, 3. They don't provide for types 4 and 5. So that's when, if the structural note would have been blank, it would have been more clear. Another structural note said, the grout thickness between the block unit and reinforcing steel shall not be less than 1/2 inch, and the adjacent bar shall not be less than 1 inch, or the bar diameter, whichever is greater. That's a fine structural note, but it's not needed. A better one would be nothing. And why is that? Because that's all covered in the code, in the standard, in the reference standard. If you look at TMS 602, Article 3.4.B.3, it provides for the 1/2 inch for coarse grout. And if you look at Article 3.4.B.5, it provides for the 1 inch or 1 bar diameter, whichever is greater. So it's already provided for in the code. The structural note was redundant, and if the code changes to something more, something less conservative, more strict, then the structural note is going to be inaccurate. I like this one too. If work is stopped for more than an hour, provide a horizontal construction joint by stopping the grout 1.5 inches below the top of the block. The intent of that is not bad, but the problem I have is with one word, if work is stopped. What does that literally mean? If I'm laying the block and I stop work, I better make sure that my grout has a keyway to it. I'm sure that was not the intent. Putting the language stopping grout 1.5 inches below, that was okay. That was kind of cool. Okay, it would be better saying if placement of grout instead of work is stopped for more than an hour, provide the horizontal construction joints by leaving a 1.5 inch keyway. That would have been a lot more clear, and that would have followed the intent of what the designer wanted for sure. If you look at the TMS 602 Article 3.4F, that has a provision for the grout key, so I think we'd be in pretty good shape. Okay, the summary here, and we're going to have about a minute left for questions if you have them. The three most important items of inspection are going to be the placement of reinforcing steel and joint reinforcement. You want the location to be where it's supposed to be. You want to make sure there's proper grouting of the grouted elements and that there's adequate connections, because I've seen failures of connections associated with grout very often, and we want to make sure that that doesn't happen. As far as navigating the code, the inspection requirements must be determined by the designer. I, the contractor, can't tell you, gee, I like quality assurance level 2, that's what I'm going to use. No, it has to be indicated on the plans. And there's some tables that force you into the minimum quality inspection requirements. The history of inspection, it's not new, but it's becoming more defined and clear over the past 20 years, which is really a good thing, because then there's a lot more communication between the designer and the contractor. And follow the ASTM standards. You're going to be in much, much better shape if you do, rather than trying to restate them in your project documents. The critical elements of inspection start with the minimum inspection requirements, then add as needed. And then you make sure that your inspection team, whether it be the lab, field testing technicians, or the inspector, that they're qualified, and make sure the project documents clarity leads to quality. Sometimes less is more, which I've emphasized here. Overstating or overspecifying might not be a good thing. And notes should be for clarity, not redundancy. And always, and if you can't do this, it's going to automatically happen if you specify it correctly. Watch for changing and approved standards. As I said, I was going to be redundant, and here I am. Placement of reinforcing steel, important. Proper grouting, important. And adequate connections, they too are important. So that's the fun slide. Thank you for listening. There's the contact information. It's on your printout, and this is another fun slide too. Any questions? Good. You can all go home. Thank you.